Okay, so let's consider another example. This time we have f of x equals cosine of e to the 2x. So we have e to the x inside of a trig function, so we are going to need to do our substitution here. So here we would let u be the e to the 2x, so we're going to have cosine u. So we just do derivative of the outer function. Derivative of cosine is sine, negative sine, of e to the 2x. And then by the chain rule, we work our way in. We do the derivative of e to the 2x. Well, derivative of e to the 2x would be itself times the derivative of its exponent. And then we just clean this up a little bit and get f prime equals negative 2 e to the 2x times sine of e to the 2x. And so now we have the derivative of cosine of e to the 2x. And if we needed to, we could do the second derivative. The second derivative is going to require us to do a product rule if we were going to do that. Another example, this is one kind of review, something we haven't done for a while, and that's implicit differentiation. So here we have a function x squared plus 2x e to the y minus y squared equals 0, and we want to find dy dx. We want to find dy dx. So remember, the process for implicit differentiation is we go through and differentiate. Remembering anything, something's next to each other, that's multiplication. So we have to use a product rule. And then remembering anytime we differentiate something with respect to x that isn't with x as a variable, we have to invoke the chain rule and put in this case, y prime or dy dx. So as we go through here, derivative of x squared is just going to be 2x. When we come to the 2x e to the y, those are next to each other, so that's a product. So we use the product rule. That'll be 2x times the derivative of e to the y, which would be e to the y times the derivative of its exponent, which would be y prime or dy dx. And then plus e to the y times the derivative of 2x, which is 2. And then don't forget about the y squared. Derivative of y squared would be 2y. And don't forget the y prime. And then that's all equal to 0. And then we need to solve for y prime or dy dx. So first things first, I'm going to notice that both of these pieces have a y prime in them. So I'm going to keep them on the left-hand side. Take everything else, the 2x and the 2e to the y, move that over to the other side. And so as I'm doing that, these two terms have a y prime in them, in each of them. So we're going to factor out the y prime. We'll have y prime times 2x e to the y minus 2y. And then on the other side, moving those terms over, we'll have a minus 2x and a minus 2e to the y. And then we just need to solve for y prime. So solving for y prime, we just need to take this quantity here, 2x e to the y minus 2y, and divide that into both sides. And that will give us y prime equals negative 2x minus 2e to the y, all divided by 2x e to the y minus 2y. And so now we have our derivative. Now we have our derivative. And so pretty messy function that we had here. If you actually look at its graph on something like Desmos, it is a really weird looking graph. And so yeah, it ends up having a rather weird, strange looking derivative. That's implicit differentiation, and really nothing new other than the fact that the derivative of e to something is that something times the derivative of the exponent. Okay, so hopefully these examples will help you as you start to work with derivatives with e to the x. In our upcoming videos, we're going to talk about integrals that involve e to the x.